Dear students, welcome to lecture 3 of module 1. So in this lecture we are going to discuss photodimerisation reaction of cyclic diene and aromatic system. So now let us discuss cyclopentadiene reaction. Let us take cyclopentadiene system. When you are going to irradiate this reaction mass in presence of sensitizer. So here for a cyclic system with sensitizer, without sensitizer, your product will differ. This is without sensitizer, direct irradiation. In presence of sensitizer, what will be your product? So in presence of sensitizer, you will get three products. One is dimerization. This is pi 2 plus pi 2 addition. The pi 2 addition. Okay. And second product will be, your second product is so this will be your second product. This will be your second product. And so first product, second product is due to pi 4 pi 2 addition, and third product is so this will be your third product. Okay, this is also due to pi 4 pi 2 addition. Pi 4 pi 2 addition. Okay, now let us discuss this. So this is pi 2 addition. So pi 2 addition means, so here also biradical mechanism, but I am going to write the concerted mechanism to avoid time delay. I am going to draw a concerted mechanism like this. Mechanism is biradical mechanism. Okay, you will get first one as the product. So here 2 electrons, another 2 pi electrons. So therefore this is pi 2 addition. This is called as pi 2 addition. Okay. Now if you take, this is one type of addition. Another type of addition, let us redraw the structure for our convenience. Okay, to understand the mechanism, for time being, I'm not going to put this to understand the mechanism. Finally we will add. Let us consider this as a handle. For time being, you forget this handle. Okay. Now you are going to have another molecule, second molecule. So here also mechanism is a biradical. Initially you will get a biradical triplet state, then it will react with another molecule. Okay, but for time being I am going to avoid. So new bond formation between these two centers. So if you add 2 bonds, then 1 2 3 4 5 6 membered ring. So as usual, here we can draw a bent structure of 6 membered ring, and here there will be a pi bond formation, pi bond. Now you can add a handle as a bridge. This is the handle. Finally you can add after drawing the mechanism. Okay, now this ring will go to, so this ring will go either to endo side. If the ring goes to endo side, that is towards the cavity downside, then hydrogens will be there at exo position. If ring will take exo position, then hydrogen will go to endo position. So this is the structure of second. This is one possibility. Similarly, by similar mechanism, third product. also possible. That is, ring will be there at exo and 2 hydrogens will be there at endo position. Okay, now here addition is pi 4 pi 2 addition. Reason, 4 electrons in this ring involved in the mechanism and 2 electrons from this ring will involve in a reaction. So therefore pi 4 plus pi 2 addition. This is known as pi 4 plus pi 2 addition, and you'll get 2 product. Now here all the 3 products will be having equal proportion. Okay, equal proportion. Equally you will get all the 3 products. 1:1:1 ratio. For some time endo position will be the major product, but exo will be the fraction, very fraction, little fraction, but almost all the products will be there with equal proportion. Okay, now so in presence of sensitizer he'll get 3 products with equal proportion. Without sensitizer, if in presence of sensitizer your cyclopentadiene will undergo excitation. Sensitizer will interact, triplet state sensitizer will interact with your cyclopentadiene, and your cyclopentadiene will undergo excitation to reach triplet state, excited state. So triplet excited state, one molecule will interact with another molecule to give you a product. Okay, but in the absence of sensitizer, as already we discussed in the lecture 1, your substrate will reach singlet state, singlet excited state, but from singlet to triplet conversion will take more time. That is, inter-system crossing rate of conversion of singlet to triplet with respect to alkene is very less. So therefore, by being in singlet state itself, your cyclic diene will undergo reaction. In isolated diene there is no reaction. Okay, but here by being in the singlet state, but here initially your diene will undergo excitation and it will be there in first level singlet excited state. So one molecule will be there in singlet excited state, and this molecule will not interact with the second molecule. This will not interact with the second molecule, since already we know energy is very high, lifetime is very less. So therefore intermolecular reaction is not possible, but intramolecular reaction is possible. Already during pericyclic reaction, so when we discuss pericyclic reactions, already we discussed electrocyclic reaction. So here also this reaction proceeds, the reaction is electrocyclic reaction. Okay, that is, so this is equivalent to this one. Four-membered ring will be there in one plane, and your 3-membered ring, this carbon will go down and 2 hydrogens will take up sign. So this will be your product. Without sensitizer, your product structure will be looking like this. This will be your product. With sensitizer, previously we discussed, we'll get 3 products, all the 3 products with equal proportion. Okay, now this reaction is not possible. Interaction of the singlet state with the ground state alkene is not possible, because lifetime of this singlet state is very less, so existence also very less. So probability of collision with this ground state molecule will be very, very less. Instead it can undergo intramolecular reaction and you'll get your product, electrocyclic reaction type of. So you'll get your product. Okay, and similarly cyclohexadiene also will undergo reaction to give 3 different products in presence of sensitizer. So when you are going to irradiate cyclopentadiene in the absence of sensitizer, then you will get your product as a bicyclic structure, and it proceeds through electrocyclic reaction. This is the mechanism, and you will get your product. So I missed to indicate a pi bond present in your product structure while teaching in a board, here you can refer the correct structure. So here you can find two reactions. First one already we discussed. If you take second one, cyclohexadiene, if you radiate your compound in presence of sensitizer, you'll get 4 different products. First one and second one due to pi 2 addition, and third one and fourth one is due to pi 4 pi 2 addition. Third one will be very trace, and if 1, 2 and 4 will be in equal proportion. First one is trans and second one is cis form. Now let us take aromatic system. If you take aromatic system, we take benzene. This is a very simple basic aromatic system, benzene, in presence of light, direct irradiation with the 250, around 250 nanometer wavelength. If you are going to pass a light with a 250 nanometer wavelength, your benzene can form biradical, but it cannot undergo dimerization reaction. So photodimerisation reaction is not possible. Dimerization reaction is not possible. For benzene. Reason is the formed biradical is highly unstable. So once again, like a previous one, this one also can undergo intramolecular reaction, and you will get, so initially it will form a biradical. Let us assume this radical formation. Okay, let us assume this radical formation. If you have like this, let us take one pi bond. This will form a biradical, and this radical will interact with this carbon. This carbon, and you'll get new bond formation. And this radical, so here you'll get another radical will come and sit on this carbon, and now between these two carbon, these two electrons will combine, and it will form okay. So this is benzoylene, isomer of benzene, another isomer of benzene. This is highly unstable, so therefore this will undergo intramolecular reaction instead of intermolecular reaction. If intermolecular reaction is possible, then you'll get dimer, but that is not possible here, so you'll get benzoylene as a product, one product. And another product is, if let us consider this. Okay, if this radical will react in this way, here there will be the pi bond formation, and here already we have a radical, and one electron will come and sit on this carbon. You'll get this type of biradical, and this biradical will form a bond, and you'll get, so this is the equivalent structure is benzene structure, divorbenzene. This is divorbenzene, another isomer of benzene. Okay, and one more product is fulvene. I'll add the structure. This is another product from benzoylene. Again, this will undergo a radical reaction, and you'll get fulvene as a third product. So your benzene cannot undergo dimerization reaction. So for that only I am writing this reaction. So no need to write this reaction, but you have to understand and you should know why benzene will not form dimer. Okay. Now let us take similarly, naphthalene also cannot undergo dimerization reaction, but substituted naphthalene can undergo dimerization reaction. Okay, I'll put in slide reaction example in a slide as reported in standard reference books. I will add the reference also. It cannot be understood why substituted naphthalene can undergo dimerization, but naphthalene, unsubstituted naphthalene cannot undergo dimerization. Like benzene, it cannot undergo dimerization. If you take anthracene, anthracene can undergo dimerization. Okay, anthracene can undergo dimerization in presence of sensitizer. It can undergo dimerization, and you'll get a structure like this. Okay. So you'll get a dimer structure like this. Now you'll be able to understand the mechanism. Initially biradical formation, single headed arrow. You'll get a intermediate structure like this. I mean excited state. Biradical structure will be like this, and this will interact with another anthracene molecule, and there will be a bond formation between this carbon and a similar type of another carbon in ground state molecule, and you'll get your product. So this will interact with ground state anthracene, okay. So this is excited state molecule, and this is ground state molecule. This can interact with, and you'll get this product. Okay, thank you. Here is another example for dimerization of aromatic system. So other than anthracene, naphthalene, if you take naphthalene, unsubstituted naphthalene will not undergo dimerization reaction. But if you consider substituted naphthalene, especially these three derivatives, OCH3, OET, CN substituted naphthalene will undergo dimerization, but unsubstituted naphthalene and other derivatives will not undergo dimerization. So these are the other examples. Cyclohexene in presence of paraxylene will undergo dimerization to give three different products. The dot denotes hydrogen projected towards you. At the dotted carbon will have a hydrogen. That hydrogen will be projected towards you. So that denotes projection of hydrogen. And second example is 7 carbon system. Third example is indiene system. So these are the references for Model 1, Lecture 1, 2 and 3. Thank you.